Hello everyone, this is Surabhi here from ChampStreet.com. Today we are going to learn about polynomials and identities. To start with, what are polynomials in algebra? In algebra, polynomials are nothing but algebraic expressions which consists of variables, constants and coefficients. So what are variables? We have variables, constants and coefficients which are related to one another with the operations, arithmetic operations such as addition, subtraction, multiplication, and division. So, what are variables? Variables are the alphabets which we use to represent the unknown values. It could be A, B, C, X, Y, Z, any alphabet, P, Q, R. Commonly used variables will be like X, Y, Z, A, B, C. So these are the commonly used variables. Now comes the constant. Constant is nothing but the value that remains same throughout the operations. So basically constant is a real number. Real number can be negative, positive, fraction, decimal, whole number, right? It could be anything. So that's the constant. What are coefficients? Coefficients are nothing but the real numbers that are actually associated with the variables. So let me give an example. So pi x plus 6y plus 7z plus 8y square. So this is an algebraic expression, correct? Yes. So here, what are the variables we have? We have x as a variable, y as a variable, and z as a variable. Again, y square, y is the variable. The power of the variable is changing. Power is nothing but we have exponents. I hope all of you have learned about the exponents. The power, like y square is nothing but y into y. How many times the y is multiplied by itself is given by this power. So the variable remains the same, the power changes. So this power is very important because we will come to the degree in the next part of this video. So here we have variables phi, so x, y, z, and y again. So if we add another term, we have multiple terms. As the name suggests, polynomial is nothing but many. Poly is many, nomial is nothing but terms. So many terms, like algebraic expression with many terms, is called a polynomial. We'll see the classification also in the next part of the video. So if you have another number 9, so 9 has no association with any variables. So it is the value of this going to be same. This term, the value of 9 is not going to change if we change any value of the variable, right? So 9 is going to remain the same. So 9 is the constant here. X, Y, Z are the variables. You can give any value to these variables, and thus the value of each term. Here 5x is one term, 6y is one term, 7z is one term, and 8y square is another term. So whenever we change the value of the variable, the value of each term also changes, right? Also here, if we can see, there is a numerical part and there is a variable part in each term. So numerical part of it is called the coefficient. Coefficient of x is what? 5. Similarly, coefficient of y is 6. And z is 7. Coefficient of y square is 8. I hope you're getting this point. So till now we have learned what are variables, constants, and coefficients. Correct? So now comes another main condition for the polynomial. So the polynomial should contain what? Variables, coefficients, constants, right? If Constant is missing also, there is no problem, but the variable should always have a coefficient and variable should be there because it's algebraic. We are dealing with algebraic variables basically. So variable should be present in the polynomial. The number of variables can change, correct? It can start with one, at least one is the bare minimum, and it can go up to any number of variables. So multiple variables is not a problem. But we have one problem. That is, if we, let's take an example, like we have 6 by x, right? So if we have 6 by x, if we, and we will compare it with 6x. So both are having variable. Yes or no? That's algebraic terms. Yes. But the thing is there a difference between 6x and 6 by x? Yes, of course. One is multiplication, the other one is division. There is one more difference, being 6x is a polynomial, 6 by x is not a polynomial. Why? Because here the power of x is 1. But if you take 6 by x, it is nothing but 6 into x power minus 1. So the next condition for an algebraic expression to become a polynomial is nothing but the power of the variable, right? So the power of the variable should always be a natural number. So it should be 1, 2, 3, 4, 5, so on, right? You know what are natural numbers. Can it be 1.5? It is a positive number. No, it cannot be 1.51 and no decimals, no fractions, nothing. We should have natural numbers as the power of the variables. Then only that particular algebraic expression is called a polynomial. So what are the things we learned till now? We have learned that polynomial is nothing but the group or a mathematical expression which consists of variables, constants, coefficients, and also the power of the variables should always be more than or equal to 1, right? So it starts from 1. It should always be a natural number. So to start with, we can start with some examples. That is 2x plus 5y, 2xy plus 7z. We can take more, 3 cube, 3x cube plus 5y square. One more if we want to take, we have 9a square plus 6c, something like this and all. You can have one more term. We can take it as 1b, right? So in the first, we see that there are two terms, two variables. In the second, we see there are three variables and two terms. That means there are two variables in one single term. Can this happen? Yes, of course it can happen. There's no rule which says one term should contain only one variable. It again depends on what kind of equation we are dealing with, right? So here if we see, there are two terms. One of the term is having the power 3 and one of the term is having the power 2, right? So if we see here, there are three terms, there are three variables, and the powers of the variables are also varying. So is this a polynomial? Yes, of course this is a polynomial. So these are the examples of polynomial. Now we are going to learn how the polynomials are classified, right? They are classified based on two criteria. One is based on the number of terms, and the other one is based on the power of the variable or power of each term. So since polynomial is nothing but many terms, we are going to use this term a lot. Okay, so please bear with me. So classification based on number of terms will be monomial. Second one will be binomial. Third will be trinomial. From number of terms, if it increases beyond 4, in general, we call it a polynomial. Okay, so if we see here, we can see here, a polynomial with one term is known as monomial. A polynomial with two terms are called binomials, and polynomials with three terms can be trinomials. So basically, they're not giving any restriction saying you should have this many number of variables, but it's just that you have these many number of terms, right? So monomial could be phi x y z, or just x, just y, just z, right? So a square, b square, c square. If you see, term is nothing but it is separated by, the algebraic expressions are separated by plus or minus, right? So these are the terms formed in the expression. So here we see it's just the multiplication. We can have this by 3. This is also a monomial, correct? There is no plus or minus inside the expression. So these are the examples. You can have one variable, two variable, multiple variables in one single term, doesn't matter. So this is the example for monomials. Now let us see binomials. What are binomials? Binomials are nothing but, oh, one thing you have to see, the power of each and every variable is always a natural number. Here it will be 1 1 1 1 1 1, like a b c, all the three variables are having the power as 2. So that's also not a problem. Binomial is nothing but, now we should have two terms, right? That is, each term will have a separation between them in terms of plus or minus. So can x minus v a binomial? X minus y be a binomial? Yes, of course. So ab minus c, this is a binomial. Phi x square plus y is a binomial, correct? So these are the examples of binomials. Like you can have any number of variables in one particular term, but there should be two terms, right? So you can have like x plus 9. You can have one variable and one constant, right? In terms of monomial, you cannot have one single constant as a term. If it is just the constant in that particular term, what will happen? It won't be algebraic anymore. For an expression to be algebraic, we always require at least one variable to be in one of the terms. Since this monomial is containing only one term, that's the main condition. So that particular term, that particular monomial should have an algebraic variable. Okay. So now comes trinomial. Trinomial, as the name suggests, it is nothing but three terms. The number of terms are 3. So can we write it as a plus 2b plus 3? Yes, there are 3 terms, right? A and b are the variables. 3 is a constant. It can be there. If one of the, since you should have at least one variable. X square plus 2x plus 1. Is this a trinomial term? Yes, of course, this is a trinomial term. XYZ minus ABC plus 1. Is this a trinomial? Of course. Polynomial in general could be of the form A1, wait. Polynomial in general can be of the form P of x is equal to A0 plus a1x plus a2x square plus so on plus an x power n. So as we are seeing, we have taken a polynomial in one variable. We can take a polynomial in any number of variable. Just for the sake of understanding, we will take this generic form. So polynomial in x can be of the form a0. A0 is a0, a1, a2, a3, so on up to an are nothing but n plus 1 real numbers, right? Here a0 is a constant, a1, a2, a3 are coefficients of x, x square, x power 3, so on up to x power n, right, respectively. So x, the power of x is varying. This is a generic form of polynomial. Now, there is the second classification based on the degree of the polynomial. Degree is nothing but the highest power of the polynomial, right? How do we know the highest degree? Highest degree we know. So the polynomials are having the power as natural numbers. So the highest number will be the highest degree. Yes, easy. Let's take a few examples. If we have 5x square plus 5x plus 5. This is one of the examples, right? So if we see here, the variable, there's only one variable. So it's very easy to compare. So this term has x power 2. 2 is the power. This term has x power 1. And this is nothing but x power 0, right? So among 2, 1 and 0, which is the greatest number? Of course, 2 is the greatest number. So the degree of this, right? Degree is equal to 2. Similarly, if I take more number of variables, say for example, I will take 5y square plus 11z square minus 6x plus 1. So this is the polynomial. Yes, because all the powers of the variables are positive, right? There are 4 terms in this. Everything's fine. Now, if you want to see the degree, this term has a degree 2. This term has a degree 2. This has degree 1 because the power of x is 1. And this is 0. So among 2, 2, 1, 0, which is the highest, either you can take this 2 or this 2. It will be the same. So degree is equal to 2 again. Now, till now we saw each term was containing only one variable. The power of the variable was varying, but each term contained one variable, right? So what happens if we have more than one variable in one term? So then what happens is we'll have 5xy plus 6x cube y square plus 3xy square minus x power 4 into y power 4. Is this a polynomial? Correct. It's a polynomial. So here, when we have more than one variable in one term, what we'll do is we tend to add the powers of the variables. How many other variables it is there? Okay, let us take one more thing. Let this last term be having 3 variables. So this has power 1, 1. So 1 plus 1 is equal to 2. This has 2 variables again. One of the powers is 3, one of the powers is 2. We have 5. Here, one of the powers is 1, one of the powers is 2. 1 plus 2 is equal to 3. So the power of this is nothing but 4 plus 4 plus 1, that is equal to 9. So among 2, 5, 3, 9, which is the greatest number? 9 is the greatest number. So degree is equal to what? Degree is equal to 9. So now you know how to find the degree of the polynomial. So based on the degree of the polynomial, we have another set of classification, namely linear polynomial, quadratic polynomial, we have cubic, biquadratic, and in general nth. Like if you have more than 5, what will you do? We'll call it as nth degree polynomial where n is equal to that particular power. So linear is nothing but the power, the highest power of any variable in this particular polynomial will be 1, right? So that means every single term of this polynomial can contain only one variable, and that particular variable should always have the degree as 1. So I will give you multiple examples. In general, I can write it as ax plus b, right? Here the number of terms is not a problem, only the degree. So here the highest power will be 1. So I can take next one as ax plus by plus c, correct? So in this, we have two variables. Number of variables are 2, but the powers are 1, right? Similarly, if I have 3 variables, what will happen? Ax plus by plus cz plus d. You can take any variable. It could be 5a plus 2b plus 3c. That's a polynomial. A, B, C are the variables. And it's a linear polynomial because all of the powers of the variables are equal to 1. So quadratic is, the power is 2. The highest power it can have is 2, right? Of course, it can be monomial, it can be binomial, it can be trinomial. The number of terms is not at all a big issue. So for monomial, I can write it as ax square, right? So this has a variable whose power is 2. Can I take it as 5xy plus x minus 2? Is this a quadratic polynomial? Of course, because the power will be 2, right? So the power of the this thing will be 2. Similarly, can I have x square plus x minus 1 is equal to 0? Yeah, it's also a quadratic polynomial. So I hope you understand your understanding. Can I have this x square minus 1? This is also a quadratic polynomial because the power of the variable is 2. So cubic, as the name suggests, the power will be 3. Bi-quadratic, the power will be 4. And in general, nth degree polynomial means the highest power is equal to n. Fifth degree polynomial is nothing but the highest power of the variable or highest power of one particular term is equal to 5. If it is 6, then the highest power of the algebraic expression will be 6. So it goes on. So till now, what have we learned? We have learned about what are variables, coefficients, constants, how they group up to form an algebraic expression, which is a polynomial. What are the conditions for an expression to be a polynomial, right? Classifications of polynomial based on the number of terms. Classification, degree of the polynomial, we learned what are degree of the polynomials. Then we learned what are the classification of polynomials based on the degree, that is linear, quadratic, cubic, biquadratic, and nth degree, right? So till now we have learned this. So before we wrap up the video, we have one small thing. We are going to derive the identities, the main identities which we'll always remember in mathematics, right? So a plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. And a plus b into a minus b is equal to a square minus b square. So many people think that we have to by heart this, right? It's not so. It's very easy. If you don't want to by heart, it's fine. Don't by heart. Don't mug it up. You can always derive this at the spot in the examination, right? Within 1 minute. So how is it? We know how to do the binomial multiplication, right? So a plus b whole square is nothing but a plus b into a plus b, right? So this is nothing but I'm going to multiply the second. I'm going to split the first binomial and multiply each term of the first binomial to the second binomial, okay? So it will be a into a plus b plus b into a plus b. So we have converted binomial into binomial as sum of monomial into binomial plus monomial into binomial. So it is a into a plus a into b plus b into a plus b into b. A into a is a square. This will be ab plus ba plus p square. Now quickly tell me if multiplication is commutative or not. Of course, it is commutative, right? So I can write it as AB plus AB plus B square. So this becomes A square plus 2AB plus B square. How long did it take? 40 seconds? 50 seconds? Very easy, right? So we will quickly find out what is the derivation of this. So it's nothing but A minus B into A minus B. So we'll have A into A minus B minus B into A minus B, A into A minus A into B minus B into A minus B. Can I write it as plus into minus B into minus B? So this will be A square. This will be minus AB. This will be minus BA. So it will be minus B square. Minus into minus B square is nothing but plus B square. Since the multiplication is commutative, I'm going to take minus BA as minus AB. So A square minus AB minus AB plus B square. So A square minus 2AB plus B square. Easy. Do I have to memorize this? No. If I don't memorize it also, no problem. I can derive it at the spot. So now we have A plus B into A minus B. This is also an important identity. So it's nothing but A into A minus B plus B into A minus B. So A into A minus A into B plus B into A plus B into minus B. So I have A square minus AB plus BA minus B square. So A square minus AB plus AB minus B square. This and this gets cancelled. What is left? A square minus B square. I hope this class was informative. By the end of this class, I want to just give you a small this thing. Using the last identity, please find the answer for 93 minus 93 whole square minus 7 square. If you apply the identity, it is going to be very easy. Please do try. And for more information, you can join champstreet.com. Thank you.